So welcome to the seminar. Almost back in time, but I'll do my very best. You see, it's a seminar, so it's the poor man's version of the lecture. There is no animation or so. Maybe the important things first. What are we doing and when are we doing that? So we have already discussed that a bit in the lecture. What is the seminar about? At the end, you want to set up a company for the production of a dipeptide. So if, and this idea originally comes from our instructors in downstream processing. For example, Martin Grehenbrink, they worked in a company called Sysal where they produced these dipeptides. And therefore we decided to set this up based on this company, based on their topic in the company. They have changed another company. We might also change then or adapt the focus of this project. But for this winter semester, this was hard because everybody was running around trying to get things done with all this Corona stuff. So that was a bit too much. Therefore, we stay now for this semester for this dipeptide. So what you do is kind of relevant because this is really in a company being translated. So what your job is, produce this dipeptide and make a company around. So the description, the full description is on Moodle. Now, you said, I didn't really read it because you told it this morning, and you're right. So at the beginning, it's not mainly about the project, it's mainly about the program, because there are a couple of things which are in this setting. Number one, of course, you want to produce this dipeptide. This means there's some economics around and so on. But the central part around which this is built is the process. So you should set up an industrial biotech process. And this process, of course, should contain everything, upstream, downstream, and so on, and economics. Now we are at the software part. The software which can do that is called SuperPro Designer. This software is designed exactly for this task, to build up a process, to scale a process for production of a biological. You can also produce something else, but this is what, let's say, the basic intention of this is about. Now, this means, in other words, that you need to learn the software, how to use the software. And this software is not an educational software. This is a professional software, which is actually used in industry. So this means that it's not primarily designed that it's easy to use. It's primarily designed that you can do virtually everything. And therefore, at the beginning, you need to learn how to use that software. Now, normally we would do that. We would sit together in the PC pool, and I would let you do most of the things, and I will walk around and look what you're actually doing. Now, we're not in the PC pool, obviously. Everybody sits at home, and I've shown you how you can log in to the PC pool via remote and to access the software. However, for this seminar, this is the reason why I decided to do it not as a WebEx meeting, a real seminar, but as a YouTube live stream, because the access in real time and so on to this virtual PC pool somehow has delays and so on. It's not so easy, depends on your internet connection and so on. So this means when we do these things live, this doesn't really work, because in the meantime, it takes hours for you maybe to get things running, and then the delays are too long. So therefore, it's less the introduction in this case is a bit less introductive. It's less interactive. This, in other words, it means that I will show you the examples, and some parts of the examples you then should do until the next lecture. So when we have the next seminar. So therefore, I put these quite densely now. So we start now, and we will have the next date on Friday, so that you in these 2 days can try to get that done and can try to work on the examples, and then we will discuss that, and we will go on, and then we will then again the next things you do at home, and then we start the next week, for example. This is how we proceed here, because others in other meetings it's not possible. The good news is that you have an access always to the software. Now, as the access is a bit more difficult with this, and as the feedback is not so intense, normally you would have each week is the seminar with the software with me next to you, checking what you're actually doing, and this is also not really possible here. So what we do actually is that we will then later on meet regularly, that's clear, but what you need to deliver is then not a complete full process from the medium preparation upstream down to the last purification step. It's just a step process, which is the fermentation at the end, and the centrifugation and one purification step, full stop. And this is what you need to do. What you need to at the end demonstrate that the mass balance and so on is working, and that's the point with respect to the process. However, remember, the process is only a part of the project. You can read that. So we start now with how to set up the process. I did explain you how to work on the software. In parallel, you should think of what could be my market and so on. But now we concentrate on how we can use the software. So therefore, it's not an issue yet that you didn't have, that you're not associated yet to the groups and so on, because you need to know the software anyhow. And then you're in a team, and then you can distribute tasks that someone takes care about market. What market can we use? Someone takes care about what should we use as let's say products and so on. So, and then also we will then have a look how we design these sessions. At the beginning, again, it's about learning how to use the software, and I register this, of course, and then it's on YouTube, and then you can watch it, and then you have the chance to check from time to time into the examples how to do it, but you have to try it yourself in order to develop it. So this is let's say the basic idea behind. And now let's first have a look whether there are questions. So first to the seminar. So these seminars are all successive. It's not a repeated seminar and so on. So now we start, we go on next Friday, we go on next Wednesday, and so on. So these are all, you should follow all the seminars. It's not that it's repeating something. Yeah. So it's all different. Follow them. Yeah. It's just, I want to concentrate learning how to use the software at the very beginning, that we don't lose too much time. Of course, also for me, it would be more comfortable to do that each week. However, then you start to know how to use the software on Christmas, and then you don't have enough, there is no time left for doing the things. Assessment, when do they start? I will tell you. So the assessments, it's of course not for the seminar, it's for the let's say the lecture part. I think they will start, if they start, they will start after next lecture. But I will, of course, tell you within the lecture when we will start with the assessments. Yeah, don't worry. Okay, so I start now the SuperPro Designer. You see on my mess on the screen. So, and now the first question which is asked is, what would you like to do? Start a new process file, open your last process file, open another process file, or we'll choose later. Of course, in this case, we start a new process file. So, and now the next question is, what process operation mode do I want to do? Most process operation modes will be batch processes, but you can also go for continuous processes. In this case, for example, wastewater treatment plants and so on are really in a continuous mode. But in general, most processes will be batch operation processes. So this, I don't care at that point. I just start now and say, okay, a batch process, we start. Okay, here we go. So here we are. So this is how it looks like if we just open the software. And what we want to do is, so what we're working on is the first example. So this is hopefully the document you also have next to you. And this is what we will have a look at. So our first example is a very simple example. It's just neutralization of an acid with a base. So this is not rocket science chemistry, but this is just to show you how the software really works. Now I also make it a bit bigger because usually the symbols and so on this software are really small and hard to see. Now it should be a bit easier to see for you. Okay, now here we go. Now let's start. So I know that you didn't have really the time to read it because I was a bit late to tell you it's a good idea to have a look inside of it. It doesn't matter. We go through it step by step. So you see the purpose is that we want to set up the simple neutralization process. And what we want to do is we want to neutralize 20% acetic acid with 15% sodium carbonate. This is not rocket science chemistry. These are chemical processes I like. You know, my friend Frank Platte, he goes for other chemical processes. Nobody understands. This is chemistry everybody can understand. Yeah. So Frank, if you should ever watch this video, this is the chemistry we like here. Learning intention, what should you take with this? You should simply learn the basic steps, how to set up something, a simple procedure in SuperPro Designer. And you should learn how to adjust process parameters, formatting based on the actual question, and how to implement economic parameters. We will do it step by step. And then at the end, how to adjust economic parameters according to the intention of the process. Okay, so the first thing to do is, if you have a reaction or a process or whatsoever, if it's a chemical reaction, you need to have a reaction stoichiometry. So you need to set up a reaction stoichiometry. In other words, if you neutralize acetic acid with sodium carbonate, what is the chemical equation? So it will be acetic acid plus sodium carbonate gives, what does it give? So, and this is the equation you want to set up. So as I am a bit late again to tell you that you should have done that in advance. Of course, it's clear that the reaction product of this neutralization process is simply sodium acetate, the salt, and you will have production of carbon dioxide and water. That's it, what you have there. And then, of course, you need to find the stoichiometric coefficients and everything is fine. This is, of course, with what you start. Okay, now we have already the parts list. We know that in our reaction, what we will have is water, because it's solved anyhow. It's reaction water and it's the solvent water. We have the acetic acid, which comes in. We have the sodium carbonate, which comes in, which are the two agents, which are the reactants. And the product is then the sodium acetate, and the product is carbon dioxide and water. So therefore, the first thing to do is, if we start with a process, we need to collect all substances we use in our process. If we want to put in substances, we need to initialize the substances in the software. So we need to initialize the pure substances. What are we doing? As described here. So we go into tasks. Yeah, so again, so it's what you register at the beginning. I'm just reading it that I don't forget anything. What you need to initialize at the beginning are all substances which are involved. So also the interim products, or in this case, if you have metabolites which you have produced and purify out in between and so on, all of them should be initialized at the very beginning. For your process later on, start maybe keep things simple only initialize things you know you need at the beginning. Yeah, don't initialize everything you can think of. Initialize everything just you need. We will talk about how these substances are dealt with internally in the next example. So now let's go. We go to tasks here. Here we go. Pure components. And then I go to register, edit properties. Yeah. Here we go. And now you get this nice little windows. And this is the components registration dialog. And now what we do is simply we search and select each component we need to add. And this is simply copy, more or less copy and paste. So here we go. Here we are. So now here we have found, this is a components database. So these components are in the database and we will see a second what that means. And we register it. Now I just click on register. And here we have then a list of the registered pure components. You have to do it then yourself. You get used to that. So this is just showing you how that works. Now we have the first component registered. Now we go with a second component. It's sodium carbonate. Here we are. Register. Oh, an alarm. So now you see component sodium carbonate is missing the following physical properties that might be needed for a simulation. Eccentric factor, gaseous heat capacity, vapor pressure, heat of vaporization. And what now? So you see that there are properties in these substances, not just the substances, but also physicochemical properties deposited in the database. And obviously, for this sodium carbonate, the eccentric factor is missing. Now, this is, of course, not a good use if you have the eccentric factor missing. Now, my question goes to you. What is an eccentric factor? I'm waiting for the response. And to be honest, I'm really curious to hear the response, because also I have no idea what an eccentric factor is. So Frank Bloody knows what a eccentric factor is. I don't know. And you see, this is an example of an information. If you have no idea what this eccentric factor is, it is unlikely that this eccentric factor plays a tremendous role later on in your simulation. And if it plays a central role, it's not good if it plays a central role, because if there is something in your simulation where you have no idea from, and this is then at the end relevant, we have a problem. So at this point, I don't care. So I have seen, something is missing. And if I see a procedure where I see, ooh, this sounds like a separation procedure where maybe the heat of vaporization comes into play, then I would go and look up this value in a tab, in a list and so on. But as long as I say, this is unlikely that I need it, then everything is fine. However, you should have a look on the list. So heat capacity, vapor pressure, heat of vaporization, you say it's sodium carbonate and it's in solution. So therefore, it is unlikely that these three terms we really need. The eccentric factor we don't know because we have no idea what it is. Okay, so yeah, okay. We don't, okay in this case means we don't care, but we have acknowledged it that something is missing. Now we go on, we have the sodium carbonate, we have the sodium acetate. I get an alarm. Critical pressure, eccentric factor, vapor pressure, heat of vaporization. So also here we have a list, and also here we say this is in solution, or this is not in our conditions. We plan to do our neutralization, that it's relevant. So also here, okay. But have a look on this list first. This is important. If you realize that something is missing, what you know, what you need, then you put it in immediately and don't wait before you get an error. So, and now we need carbon dioxide. And then everything is fine. So now we have all our substances. We have acetic acid and sodium carbonate, which are our reactants, and our products are sodium acetate, carbon dioxide, and water. And you see nitrogen and oxygen, it always puts by default, and that's fine. So therefore, we have no problem there. Okay, so we are happy, and we click now. Okay. And now, component sodium acetate. Now we come to the problem that the component sodium acetate, the pressure must be above 0. And you remember, we have neglected it. And now the software tells us, this is not a good idea to neglect that. Without this value, I don't allow you to proceed. Now what next? The trick is, we didn't care about that. And now we could, of course, look it up in tables or something like that. But this takes ages. So let's double click on that. And now you see, wow, we have here a vast array of values which are put in, the temperature, the critical properties, and so on. But what was missing was the critical pressure. We have no idea how high this critical pressure should be. However, we know that for our process, the critical pressure is of no relevance at all. So I simply put in 0.01 bar, which is certainly not correct. And I click OK. And I click again, OK. And now we have a critical pressure. And now we have registered our substances. However, you should not save that in the default database. This is registered now just for our process. This is not in the database. And of course, this critical pressure is certainly bullshit. But again, we don't care. We just want the software to go on. This is a typical example of engineering. It's not maths. I think a mathematician would never do that. But we're engineers. We say, okay, we can invest now 5 hours to look up for this value and find maybe a colleague who works since for life with sodium acetate and knows the critical pressure, or just skip it and just put something in and that's it, because we don't need it. But you should remember that, because if there is a procedure where this might be relevant, it's of course important, and you should never save such a value then in the major database. So this is not just the value which is just used for your process, and there everything is fine. Maybe I should have a brief look on whether there is a question in between that I don't lose you. Okay, So, is the semifinal to try it ourselves next to your stream? Okay, try it ourselves next to your stream. You can do it, but it will be hard. What I would do it now is I would recommend watch the stream now, and directly after I'm ready with the stream, do it yourself. And then you will see that I have some questions you need to respond to. Because if you do that really in parallel, sometimes things are too fast and you cannot ask directly, wait a second. And therefore, it's really difficult. So this will be on YouTube, so you can watch it again. What I recommend you to do is watch now. If you have a question what you didn't really understand, because you say, what's this? Ask. Then you try it again. Next Friday, most likely, we will start with a WebEx session that we can discuss your problems directly, and then we will go on. So that's at least at present the plan. So again, it's not optimal, because usually we will sit all together in a PC pool, and as we use the software you don't have on your computer, it makes no sense to make a WebEx session because you have not this software on your computer running. Initialize are different from only the reactants. All substances need to be initialized. It's the reactants, products, and so on. All products which appear, all substances which appear in your process, be it in a reaction or just as a carrier. So if you have a reaction where no water is being produced, but your water is is your solvent, then of course the water is also there. Which version of SuperPro are we going to be using? So it's the SuperPro 10, which is installed also in the rooms. Hopefully it's the 10. I think this is more important. Take this sheet and take notes and so on. This helps, I think, more. That's the reason why I said print it out. Now we want to add a procedure. Now that's the big day. We start with now adding a unit, and of course. What we do is we go to unit procedure and we add a batch vessel procedure and we add a unit procedure, batch procedure in a reactor. So what we add is now a simple vessel procedure. Here we are. So this is our vessel we have now added. So it's very simple. So at the end, the reaction is very simple. So also the reactor there is very simple. You pour something into this reactor, mix it, and that's it. Yeah. So okay. So let's start. So we have our reactor, and this is now important. You will see later on. Then in SuperPro, it's not just a picture, but there is something happening, and this is what I want to show you now. So what we do now is we add streams. So we go to this tool here and add streams. So now, as you've seen on your picture, on your example, it should then look like this. And this is what I do now. So I add the first stream here. Next stream here. Then I add a stream here. And I add a stream here. Okay, so I've just added streams with this stream tool. You see, as soon as you go next to this ports, then this changes and then this edits it. Don't draw streams just like this. Yeah, they always have to edit somewhere. So you need to start here or you need to end here. Yeah. So this is how you add streams. Do it then yourself, and then you see how this works. Now we have on the picture, it looks like we have done now everything. We have now our streams, we have our reactor, that's it. So we pump something in, we pump something out. So the picture looks complete, but we want to fill in now the procedures in this picture. We want to do the simulation. We want to, the software should do the calculation for us. Okay, so now this means that we have to initialize now the streams. Now, obviously, these are the input streams. So see, this is what goes into the reactor. This is what's going out. And you see that each port is one stream. So as we charge two substances, or better, two solutions, we charge a 20%, I don't know what is 20%, what is 15%, a 20% acetic acid, and we charge a 15% sodium carbonate. This goes into these pipes, more or less. We pipe that into this vessel, and at the end, of course, we put something out. This we talk later. Now, okay, so now what we have to do is we have to initialize the screen. So what we want to do is we want to initialize the stream 101. So we just double click on the stream. Okay, so now you see, as soon as I have double clicked on the stream, a new window is open. And this window is then, again, this is stream 101. You see that the stream is getting red. And this is then a dialog which asks us to put something with respect to this stream. Okay, here we go. So now, the first stream is our acetic acid stream. So we need to put acetic acid, and we need to put, of course, water. So this is what we put here. So now our stream has a composition of 100% acetic acid. This is a lot. And 0% water. Of course, we need to change that. It's 20% acetic acid, mass composition, and 80% water. Be careful with this mass and volume composition in real processes. Mass and volume compositions are not the same, but it was given in the exercise that this is a mass composition. Okay, now we have added that, and now we set the mass flow as depicted here, to a flow rate to 1000 kilogram per batch. Okay, so now this is 20%, 80%, mass flow is set. Okay, so now the stream is initialized. Now we could also initialize the second stream the same way. You remember this is then the sodium carbonate stream, but we will initialize it in a different way, just to show you that there are different possibilities how to initialize streams. Okay, now we set up the vessel operations. At present, we just have a picture of this vessel, but at the end, what we want to have is we want to proceed in this vessel with a reaction. So we need to tell what should happen there. So we need to add operations to these vessels. So, and what we need to do is, of course, we need to bring these things in. These things need to react, and then these things need to get out. This is the operations we want to have in this vessel going on. So what we do is we just add operations. So we go to we right click on the vessel, and then you see that there are different things appearing. So we have add remove operation and other things. At this point, we don't care about the other things. We go for add remove operations. And a new window opens. Here we are. And there are a couple of available operations. And of course, the operations depend on what unit you choose. If you have a disk stack centrifuge, the operations will be different to the operations you have in the vessel procedure. Want to know what is this unit about? Also here, right click, help. It's a good idea because then you get an overview about this process. You get an overview of the operations, and you can click on an operation like the charge operation, and then it's described for what this operation is used. So use this operation to bring a known amount of material of a known composition into a vessel via a process input stream. This sounds good. It seems that this is exactly, so this description is exactly what we need. So here we go. We do it. So right click, add remove operations. And as I said, obviously we need to charge the sodium acetate, charge the acetic acid. We need to charge the sodium carbonate. They need to react, and then we need to transfer out. So we add one charge operation, and we add another charge operation. We need to charge two things. For each stream, we add a charge operation. Then we add a react operation. We have a reaction going on in this reactor. Now you see, we could also add mix operations and so on, but we don't care. We just make it very simple now. React equilibrium, react kinetic, react stoichiometric. We remember bioprocess engineering, kinetics was so complicated, so we don't touch this button. We just go stoichiometric. Stoichiometric just means you give the stoichiometry, you tell the software, go to 80% or whatsoever, and everything is fine. Kinetic, you need to give the corresponding equations with the and so on. So this sounds complicated. You don't do that in a process, setting up processes. You don't use kinetic operations if you don't need to. Let's say an internship we had at our department was for SuperPro and a wastewater treatment plant. There you need to do a kinetic simulation, but in a general process like this, you don't do that. You just use a stoichiometric. So there we are happy. Reaction, stoichiometric reaction. And then at the end, we need to pump everything out. And this is then a transfer out operation. So now we have just added the operations we want to allow proceed in this reactor. Okay, we have added it, but of course, now these are just there. So the software has no idea. So what? What do you want to charge? So therefore, we need to, and we are now here, just that you can follow me. now we're at 2.7. We need to set up now the operations. Oops, maybe just a brief look on the chat. So the initialized substances are different from only the reactants. Yeah, I think this also I said. Yeah, you have to initialize all of them. SuperPro also said measure of amount of. Okay, should we do the example individually or within groups that we choose? Do the examples individually. Each of you should train on the software. Do it individually. Every one of you should know how to use it. Can you show us, please, how could we able to delete operations or any substances? Okay, so if you have for example, put in a wrong operation, you just go to add remove operations. And for example, the charge 2 operation was nothing. Click on it and then click on this cross. And it's gone. And if you want to bring in another charge operation, then you just add it below of this operation. And then it's here. And then you see here, you have errors. Then you can bring it up here. It's important. The order matters. Yeah, this is very important. You first need to charge and then you can react. The software will not complain if you have a different order. Yeah, this is very dangerous. Make sure that the order is correct. So charge 1, charge 2, and so on. So this is how you can delete here an operation. And the same is true if you go to tasks, pure components, register edit view, so it's the same. So you have our components here. And if you, for example, want to take out the oxygen for whatever reason, you also go to this, delete, and then the oxygen is gone. Yeah, and then of course you can have to edit again. Okay, so I want to close this dialog. Okay, now we want to set up the operations. Now we are at point 2.7, and we first of all set the charge 1 operation. So now we don't go to add remove operations. Now we have a new topic here, which is operation data, and we go to our charge 1 operation. So this is our charge 1 operation, and this is how it looks like. So you see, each operation has many things you can play around. We just concentrate now on the basics, yeah? So that you have an idea how to set it up. This is why we keep this process simple. But you see, you can do tons of different things in each operation. So we are in a vessel, in the operation, and you can do hundreds of things. So you see that there is a lot of complexity behind. And our job now is we want to bring down this complexity to a level that it's possible to understand it. Okay, so now we charge using, we need to tell the software what stream to use. So we want to use the stream 101 for this charge 1 operation. So we charge using stream 101. It's not port 1. You see on port 1 there is nothing. You just look where we have our 101 stream. That's it. And then you remember we have initialized the stream. So the amount we want to charge is the amount which is given in this stream. So everything was written in the stream. So we click here, amount, use amount of stream. And then everything is fine. The remaining part we leave untouched. So the setup time and so on, we keep. Changing default values, just a remark. Of course, it is possible to change default values. I would not recommend you to do it if you don't know why you do it. So, of course, it's possible to change default values, but only if you know what you're doing. It's better at the beginning to start a process, get a running process, and not fiddling around with all the details, because the risk is high that you end up with a process which simply doesn't work. So the typical thing is, you will see if you do it yourself, is that you get tons of error messages and you need to debug the error messages. And if you increase the complexity because you have fiddled around with 500 different variables, it's almost impossible to find the error. Because in the usual seminar, 99% of my job is going to your computer and finding the error why this doesn't work anymore, which is also for me kind of keeping my brain running, because of course the situation is different from student to student, and I have not followed you what you have clicked around. So this means don't make it too complex. Don't go from the very beginning and put in too much if you don't need it. And this is exactly what we do here. So we do not touch these values, process time, and so on. We just keep it and we use this amount of the stream. Okay, so we have initialized our first operation. Now you remember our charge 2 operation was a bit different because the stream of the charge 2 operation was not initialized. So in the stream, we have not told the software what is in the stream. So of course, for charge 2, we take the stream 102, we take the stream. But now we need to tell the software first, before we proceed, what is in. So therefore, we go to this symbol here. We go to this symbol, click it, and you see it's view edit the streams composition. And here we are, a new window opens. But the cool thing is that you have already seen this window, because this is exactly the window which gives you the stream composition. That's cool. Yeah, it's something which is not new to you. So you go there and you remember the first stream was our acetic acid stream and the second stream is our sodium carbonate stream. So what you do is you simply add sodium carbonate, add ingredient, and of course also here water, add ingredient. So now we have initialized the stream, and now the same is true. We need to correct the percentages. So sodium carbonate is 15%, and water, don't forget to adjust the water, it's 85%. So this is our stream composition. Now we don't touch here these flow rates, and you cannot change them anyhow here. So we just have given now the composition of the stream. Okay. And now we need to tell the software how much is being charged. So we cannot use the amount of the stream because the stream in this case just contains the composition. We want to set it here. So mass flow, we add also here 1000 kilograms. And the remaining things also we leave untouched. Okay, so now these are just two different ways to initialize charge operation. This is just to demonstrate you that in this software, this is often the case that it is not the case that it's just one correct way to do it. There are several ways to do it. However, if I were you, this is what I did now, using two different ways to set up streams, I would of course not recommend you to do that like this, because it's like just showing you how you can do it. What I usually do personally is I initialize the stream just with the composition at the very beginning. And this I do on the stream, that the composition is defined there. And then the amount to charge and so on, I do in the operation. However, this is not, let's say, this is not gold, that you have to do it like this, but I would always use the same procedure that you, and also this step-by-step approach. So put your unit, draw your streams, initialize the streams with the composition, and then go to your operation. It's just that you have some routine getting in, because each time you make an error, you might have an error at the end of your mass balance and you don't know what actually happened. This is the problem. Okay, so just again having a look at why do we add only one transfer out? Aren't there two outfluxes? It's a good question. We come to this transfer out stream, but it's an aqueous solution. So at the end, it's all in one. So we need to add two charge operations because we pump in this separately. Even if there is no one pipe for charges, you always use a different port. But then it's mixed inside there, and it's in just one tube at the end. So therefore, in this case, it's no more need to have. It's not separate. It's a one in one phase. Why couldn't we set the mass flow for the second stream before we add the operation? You can do that. It's just an example that there are several ways to do it. It's not just one way. Okay, so let's go on. Now we have the streams, and now let's go on with the reaction. So now we come to the reaction tab. And this is, of course, now the king's discipline. So here we are. So we go now. So we are at 2.8. So we use a Statiometric reaction model. You see what's written here. So we need to, if it's a Statiometric model, we need to tell the software about the Statiometry. The cool thing about this, the software is, as soon as the mass is balanced, the software doesn't care anymore. So you can trick a bit. You will see later on how this can get important. But if it's a reaction like this one, there is no doubt about the overall Statiometry, and it's your job to give the software the correct Statiometry. Otherwise, of course, all what will come out is rubbish. So it's important to set that correctly. Now, usually you can, of course, now set. We go now to, this is the first tab, but we go now to the tab reactions here. So not operation conditions. Here we leave everything the same, but we now go to the reaction progress. And here we have set conversion. So here we can say how much percent to convert. If you have these equilibrium conditions and so on, it could be that, for example, if you make an isomerization of glucose into fructose to produce high fructose corn syrup, then you would, for example, it's maybe 45%. But in such a reaction, this neutralization reaction, we allow 1 hour. We have set the time to 1 hour, and this will be 100%. So we have no problem here. So this is, of course, something you need to know based on your vast knowledge in chemistry what you can put here. It's the software doesn't complain. If you put in here 100% and it's an equilibrium reaction, and this can be, the software will convert to 100%. If you give a time of 1 minute and it takes 5 hours for the reaction to proceed, and you give it nevertheless a conversion of 100%, the software will do it. So it's up to you to come here with values which are reasonable. Now, we go here. Now we have to edit the Statiometry. So this is our first reaction, and we have to go to the Statiometry of the selected reaction. So we have to tell the software what is happening here. Now, we have here, we need to add our reactants, and we need to add our products. So here we go. So let's add our reactants. Of course, we have written down our reaction equation on our sheet, which is just in front of our eyes. And we have acetic acid, and we have sodium carbonate. It's not the water. The water gets in, but it's not involved in the reaction. It's not a reactant. It's a solvent. And of course, what we produce is sodium acetate, carbon dioxide, and water. So this is our reaction. We are at still 2.8. By the way, this is the old process. The first process we did is sodium chloride neutralization. I didn't change the slide, so of course this is the correct one, what you need to put. You see that now the masses are not balanced. You would need to set up the Statiometry correctly, but this is of course easier if you use, instead of mass coefficients, then Moller coefficients. So here we go. We click on Moller, and you see now also the Moller coefficients appeared. And Now, of course, you have in the meantime worked out the molar coefficients, and you have realized that 2 molecules of acetic acid react with 1 molecule of sodium carbonate, yielding 2 molecules of sodium acetate, 1 molecule carbon dioxide, 1 molecule of water. This is the reaction stoichiometry, simple. And you see then, of course, then the mass in this case is balanced. Okay, so we're happy with that. So we have added the reaction. We have added the conversion rate. Often this is forgotten because the default value there is 0. And then, of course, nothing happens. And we're quite happy with what we have done now. And so we say, okay. Now you can always say, okay. But what you can also do is making life simpler. You can click on this. You see then it's okay. In this case, if you click here, it's okay. Next operation, then you don't have to redo this right click and so on. It's just then quicker. You go directly to the next operation, and everything what you have put in is saved. Okay, next operation. And now we come to our transfer out. And the transfer out stream, this is this one here. This is this 104. So we use stream 104. Here we are. And there, everything else will leave as it is because it's just a transfer out. So it's just pumped out, and we don't have to care anymore because this is what is being reacted then is being pumped out. I just have to look on the watch. Okay. So now we're done. We have initialized the streams. We have initialized how much is being charged. We have set the operations. We have set the charge operations. We have assigned a stream to the charge operation. We have told the software how much has to be charged. Then we have set the reaction. So we have put in the reaction stoichiometry. And we set at the end and then just transfer everything out. So we're done. So that's what the software needs. And now, of course, the software should do the job for us. So we use the software in order that it can do all this mass balancing stuff. You remember your mass balancing exercises took hours. So now the thing is, you want the software to do it and not you want to do it. Okay? So now let's go. Okay, set the same to mass. Yeah, okay. So the reason why this is written is because this was the old exercise. Don't set it in this case. Go for stoichiometric coefficients. In general, you would go for masses. So most processes and so on, you use masses and not stoichiometric coefficients. But in this case, it's a pure chemical reaction. So stoichiometric coefficients are easier. Yeah. Okay, so, there was a transfer out operation can be added for either of the outstream. No, this outstream here is a good question. This outstream is a special one. So it's just for the 104 stream. I connected this 103 stream, as you have seen. I connected here, and this is the vent out. So this is a good question. Keep that in your mind with respect to another thing we will talk about in a couple of seconds. Okay, now let's go back to our operation. And now the big moment comes, because now we have set up all our streams. And now we perform the mass and energy balance. By the way, what I did not yet do is save. Don't forget to save regularly. And remember, if you work on these virtual clients, you need to save and send it to you by mail or whatsoever, because as soon as you log out, everything is lost. Yeah, so this don't forget that. Yeah, saving on a virtual setting is different than when I save something here. So I could of course save that. I should do that, but as today we just go with this example, and this what I have shown you here is of course in reality drawn in 1 minute. Let's say the falling height is not so advanced in this case. Okay, now I perform the mass balance. This is the big deal. So I go to this symbol here and I do solve the mass and energy balances. I click and that's it. And you see down here, flow sheet 1, perform mass and energy balances ended successfully. This is cool. If you have an error, for example, I'm just giving an example of how this can look differently. Let's go to the operation transfer out. Maybe I use an empty port. So if I now click mass balance, you see, now I've used an invalid port. And now you see that what you will get used to, you see error messages. Stream S04 104 is not currently be used by any operation in P1. Remember, we kicked that stream out, we used another port. Stream on output 4 in procedure P1 is used by transfer out, but it's currently missing. And therefore, the simulation has failed and the mass and energy balance is not being done. You can only proceed by solving these errors and you have to go step by step. You will see if you have more procedures, you will get more errors. Yeah. So you need to read carefully what happened. So you see, oh, there is a red, start with the red errors, the yellow errors, but the red errors. So stream on output port 4 in procedure P1 is used by transfer out, but it's currently missing. This means you have to go to this procedure transfer out and check where the problem is. Port 4 was chosen. So let's go operation data. And this is procedure 1. This is vessel procedure 1. You will see, of course, later on, if you have more procedures, how to allocate then the correct one. So this is procedure 1. Right click, operation data. Transfer out. We need to go to transfer out here. Operation data, transfer out. And now we look. So port 4. We have port 4, but no stream is associated here. So, and then we also understand the first message that we have drawn a stream here 104, which is not used by any operation. Because we have clicked the wrong port. So we have to use port 6 because there we have the stream 104 being associated. Click. Okay. And we redo the mass balance. And now everything is fine. Yeah. So this is how, I think the most important thing is how to do the debugging. Step by step. Don't look all of them. Step by step. Look at the error, find the error, remove the error, do the mass balance again. If an error is existing, do the next one. Because, for example, if you have another operation down there, of course, also this operation will give you an error because there is no transfer or something like that. But you don't care about this error. You start with the most upstream error first and correct that. And then you go to the next, do the mass balance again. And it could be solved that all your downstream errors then are solved by solving this error. Yeah? Just one step by step. Step by step is here the most important principle. Okay, so the mass balance worked. So what? Now it's a big time. We can look what really happened. Yeah. Now we can, for example, right click on our vessel procedure, operation data. You see we have all this setting. And now we want to go to equipment contents. And we want to see what is happening during our P1 reaction. And here we are. And this is what we see. So you see, this shows us now the contents during the execution of P1. And you see that this is of each, let's say, time point, we have what is the duration, what is happening, and so on. So you see at P1, we start. We have, of course, air in our reactor. Nitrogen and oxygen is inside. This stays inside the complete period, by the way. Yeah. Then we have our charge operation. And you see this charge operation takes 1.9 hours because we need to pump it in. It's often forgotten that pumping takes time in real reactions or in real production scale equipment. It's not just like pouring it in and everything is fine. You need to pump in 1 ton of water. That takes time. Yeah. Then you see this is the total mass, which is in our bioreactor. At the end, it's just at the beginning, it's just air, but then, of course, in the bioreactor, in our reactor, and then things go up. And then you see, as long as we charge, nothing happens. Then we charge the second one, and then we have our reaction happening. Of course, we are all aware that most likely, if we pump in our sodium carbonate, it will immediately react at the end. Yeah. So, but we don't care. We separate this charge and react operations. And it's not something which hurts us, because at the end, it's just important that after this time here, 4.8 hours at the end, our reaction is complete. This is the point. Whether this has started to react a bit earlier or later, it's a stoichiometric reaction. It's not a kinetic reaction, what we have set up here. We don't care. And then we have the transfer out. And of course, this also takes a while, and we pump everything out. Now you see also what we plan to do is a neutralization. So we pumped in, this already looks good. We pumped in 20% acetic acid and 15% sodium carbonate. And you see that at the end, we wanted to neutralize this acetic acid, but we only partially neutralized it. So we have 30 kilograms of acetic acid left, and we have completely consumed our sodium carbonate. You would say, well, this is not a surprise because the concentration is different. Yes, but it's a stoichiometric equation. So therefore, you would like to have there 0 and not also for the acetic acid. And if you look now, this is the content of R1. What I can also do is I can double click now on this stream here, and then I have the stream content after the reaction happening. So this transfer out automatically puts that now in this output stream. Of course, usually I would then have a downstream operation, that's clear. But you see that this is then exactly the composition of my output stream. I have 30 kilogram acetic acid. Of course, I have no sodium carbonate because this is not in the stream. I have sodium acetate and I have water. And I have only, you see in this stream, I have only stuff which is liquid. There is no gas in this stream. Okay, so this is kind of the basic setup, and I think the most important thing at the beginning is just really try out this very simple setup. Play around a bit with that. I don't want to go further today because this is as I'm not next to you. And things get frustrating with the software quite quickly if you realize that something doesn't work and nobody can help you. So what you should do now until Friday is, first, just try to get this simple process running yourself. And then as an option, and this is now the kind of the homework until next Friday, try to do this, what is under section 3, refine the process and formatting. So we have one question with respect to the pressure. We have one question with respect to adjusting the mass flow and redoing the process using mixtures instead of pure materials and to add labels. Try that yourself. If you fail with one of these sub-processes, no problem. Again, there is no grading now, interims grading, whether you managed it with a process or not. You get graded for the end product. I just want you to learn it. However, you only learn it if you do it. So if you just read the script or watch this video, this is of no use for you. Just make sure that you really have understood it by doing it. This is like if you go into a math exam just by watching YouTube videos talking about math, you will fail. And this is the same here. Practice, do it. It's very simple what we did at that point. Things get more complicated, but I think it's really important that until Friday, try to do it yourself. Yeah. Don't get frustrated if something doesn't work from these examples. Of course, we will discuss that on Friday, but really try to get the first part running. Of course, this video is available, so you can go back and check in the video. And also, this is the first part is very, very broadly described. You will see that in example 2. I don't put then 5 pages description how to initialize substances. This is what I think then what you need to do, what you need to know, and what you can look up in the example 1. This is then your reference. Okay. If you're quick, you can go further. It's not a problem, but it's not something I would recommend. I would rather recommend stay now with us until Friday at least, and then we will go on. And of course, the software is really fun. You can do so many things. So the best way to learn at the end is really play around with the software. Then you really learn it. It's not always strict following, but at the beginning, please do this example. Do try to answer these questions and to solve this question of part 3, and that's it. Don't go too much in economics and so on, and don't go into economics if the other things are not running yet. Try to make them run. So this is it, and I'm just now checking whether there are questions. Yeah, you don't initialize S104 because this is not something which you charge. You only need to initialize things which you charge. It's a transfer. So this comes from an upstream operation. It's good to check the help in this case also. So I don't need to initialize it because it's reacting, and then it's the only thing is I need to, for the transfer out, this goes into the stream 104, and everything which comes out of the reactor is then within the stream. I don't understand section 3, what that you mentioned. Can you repeat it a second? And we always have access to the PC pool. Yes. So this is the cool thing about that. Virtual access to the PC pool, you always have. Maybe if the SuperPro designer could calculate all these values, why should we do it by ourselves in Biopro? This is a good, excellent question. It can't, because if you now use a Statiometric approach and you do we do an example 2, if you grow your yeast, you need to calculate how long it takes, for example. And you need to understand what SuperPro is doing, because the problem is you can tell the software anything you want. It will do it. I think this would be the perfect playground for Donald Trump, because you can tell the software whatever you want, and it's maybe sometimes there is an error, but sometimes it just gives out a result, and the result might be bullshit, and your job is to understand what is happening there. Yeah, so that's the problem here. Okay, so look. Did you transfer out of? I didn't understand section 3 that you mentioned. So what I'm mentioning is, so this is based on the example sheet. So here, I'm just looking that it's in the camera. This is our example 1. And in section 3, refine the process and formatting. And you have here pressure, and you see what you should do. Analyze the pressure in the reactor. Do you feel comfortable with this? This you do after you have set up your own process, and then adjust the mass flow. So the point is, what we did is obviously we have 30 kilograms acetic acid left. This is not what you want to do. You want to have 0. So you should adjust it in a way that it's really also 0. And then redo the process using mixtures instead of pure materials. You can also initialize mixtures. It's described how you can do it. So do it, and also add labels in order that it looks more beautiful, that it's not, that here acetic acid and sodium carbonate is charged and not S101, 102. And also here you see the product is coming out, and this is what you can also do to make the process clear. So this is what you should do. It's not an assignment, so it's not that if you didn't do it, you will not get killed, but you should keep up the pace, because then we will proceed. And if you have never done something, then things are difficult. So if I were you, I would really concentrate on trying to follow now these things. There will be no assignment with respect to the lecture in between. So assignments for the lecture will be told really in time, that you don't need to worry in this respect. Okay, so just an ultimate look whether there are more questions. No. Then I would say thank you very much for your attention. Don't be frustrated. The software is really cool, and you learn to use a professional software package. You will be at the end very happy if you can use it. But this is, of course, something else than using WhatsApp, Facebook, or Instagram. This is really a cutting-edge software. But you can then write on your CV that you know how to use SuperPro. And this is something else than expert in Word. Everybody writes that. So this is an add-on you learn here. And of course, this virtual access is not ideal, but this is something in this semester, as you know, there is no other way. So this means at the end, thank you very much for your attention. Looking forward to seeing you again, and good